Welcome to the Pro Tips video series designed to arm biology learners with background knowledge needed to kick butt during upcoming lessons. Students are encouraged to watch these tutorials before attending lecture on the topic and rewatch them while studying. I'm Professor Workman, and today's Pro Tips introduce the metric system of measurement. The metric system is the language that scientists everywhere use to describe measurements. Height and distance, for example, are measured in meters, while volumes of fluids are measured in liters. Weight is measured in grams, and temperature is measured in degrees Celsius. Agreeing to report observations in the same units allows scientists to easily compare their data, no matter what country they work in. Scientists use metrics because it is the system most widely adopted worldwide. On this map, countries shaded in blue use only the metric system. You can see that Canada and the UK are shaded in purple, meaning that they use both the metric system and their old-fashioned English imperial system of measures that includes feet, ounces, etc. And you can see here on the map that the reason I have to make this video is that the US refuses to go metric. The United States is the only major economic world power that still employs non-metric units, like buying gallons of gasoline rather than liters, or a doctor might measure your weight in pounds rather than kilograms, even though the medical research that informs recommendations for care is published only in kilograms. In the metric system, base units like meters, liters, and grams can be easily converted into descriptions of larger or smaller increments by tacking a prefix onto the word. For example, the prefix kilo can be added to the base unit meter to create the word kilometer, which describes a bigger distance than a meter. Please see the description box for practice problems that will acquaint you with the metric system. So these prefixes convert base units to smaller or larger increments, depending on the needs of the measurer. If you're measuring the distance between two cities, you would use kilometers. But if you're a tailor measuring body proportions for a new suit, then it would make no sense to use kilometers, and instead, you'd use centimeters. In biology class, you may observe cells under microscopes, and they are very small, so you should measure them in smaller units, perhaps micrometers. An important feature of the metric system is that each step along this number line is exactly 10 times different than the previous step. What I mean is that there are 10 meters in a decameter, or 10 decameters in a hectometer, or 10 hectometers in a kilometer. Traveling along this number line in the opposite direction, as units are describing smaller and smaller increments, we apply the opposite math and divide instead of multiplying. So if there are 10 hectometers in 1 kilometer, that means that 1 hectometer is 1/10 of a kilometer. And a decameter is 1/10 of a hectometer. And 1 meter is 1/10 of a decameter, and so on down the line. You might notice that as we get to the smaller increment side of this number line, some of the spaces are not described with any prefixes. I wrote X's here to take up space and indicate that these spaces have no names. These spaces are real, and the same math applies, so between each space the increment is 10 times different than the previous step. What's happening here is that these spaces allow observers to get real small, real fast, by jumping 3 increments at once. When we do this, the math indicates, for example, that a micrometer is 1/1000th of a millimeter, and a nanometer is 1/1000th the size of a micrometer. These are very small increments indeed that can only be observed with the help of modern technology. Now I wanted to give you a visualization technique for thinking about the way that these prefixes work. The prefixes become useful when you want to describe things that are very different in size. Here you'll notice that a kilometer, this purple rectangle representing the distance of a kilometer, this distance could be described in various ways. So like a kilometer is the distance between two cities on a map, but a decameter might be better to describe something smaller, like maybe the height of a skyscraper in New York City. Now let's look at different parts of this number line, the middle part, where we have deci, centi, and milli, and here you'll notice I'm using meters as my example, decimeter, centimeter, and millimeter. And the same proportions apply. Now, consider this example. Imagine there's this giant acorn. With which of these units might you want to describe the size of this acorn? You can see that a decimeter is too big. The acorn would only be a fraction of a decimeter large. Millimeters would be really precise. We might have some, I don't know, it looks like maybe 70 millimeters. Centimeters, though, in this instance seems just right. This acorn seems to be a number of centimeters big. So I would recommend using the centimeter scale to measure this acorn. Contrast that with these little ants. Notice that a decimeter is not the appropriate unit to measure these ants with, and maybe a centimeter is also too big. So these ants, I would say, are at a millimeter scale. It's best to measure their size in a number of millimeters. This brings us to today's key term, which is scale. A scale refers to the ballpark size of something, and it determines what units should be used to measure it. For example, if we wanted to measure the weight of these three things, we would measure an adult elephant in kilograms, but a human newborn is much, much lighter, and so it would make sense to measure the newborn with a gram scale. Contrast that with aspirin tablets, which are routinely measured in milligrams, a much smaller unit of measure. In biology class, you will use technology like microscopes to extend the power of observation to extremely small scales. If you bring something really close to your face, the average human eye can see tiny dots down to about 60 micrometers big. Smaller than that, and you cannot see the dot at all. So different types of microscopes allow us to observe objects that are very small in size in order to make out distinguishing features, observe what's going on at these extremely small scales. In summary, you learned in this tutorial that scientists everywhere commit to the metric system of measurement. You learned that base units in the metric system include meters, liters, and grams, and that base units can easily be converted into larger or smaller increments by adding a prefix to the word. These prefixes are useful to measure things that are very different in size. Scale is today's key term, which refers to the general size of something. For more metric practice, please see the worksheets provided in the description box. Thanks for watching. If you liked this video, you might consider watching other videos in the series. Here's my contact information, and I always welcome any feedback. mworkman@pima.edu. Good luck in your biology journey.